Well, yeah, this is the recording of my beautiful calculator. Um, this is how it looks, and it should be working quite alright. Let's just test it. It seems to be working. Awesome. Well, if we go to the code to explain a little bit, we can see on the first line here I include the IOStream library and the math library. The IOStream pretty much the basics, and math to get some of the functions of sine and cosine and stuff like that. I'm using the namespace std, otherwise I would have to put an std in front of almost everything in the program, so that seemed to be the easier way. Anyways, I declare my variables here. I have a character variable called key and two long double values, one called screen value, which I set to 0.0 here, and a variable called new value. The reason I make it a long double variable is because they can take a lot more decimals than a normal double, and an integer wouldn't be able to take any decimals at all, so you can't need that in a calculator. Then I put in a variable of a string called action. I'll get back to that later. If we start off with my first function here, it's pretty much the display only, as we can see here. Yeah, this is pretty much it. Not much to explain there. Of course, we will be using all of these characters and operators, you might say, when we calculate. Moving on. This is a more interesting part. It's the calculation function. Basically, I prompt the user for a new value, and well. If we go down here first, we can see that this while loop is listening for any key press from the user, and it will be running as long as the key press is not a Q, which is for quit, if you notice that here. Quit application. So it's listening for any key presses, and if we start off by taking we can explain this one first. This is the clear screen case where I listen for an O, and I make it as both a small and a large O. If such a key is pressed, the screen value is set to 0.0 again, which is the start value, and then I output this screen value again as a display. This is a more interesting one with the add function. I listen for the plus sign, and I set the action to add, and then I activate the function calculation. So now we can go back and explain in the function calculation here. So since the action is add, we activate this one. Screen value is equal to, well, it's not equal to, that would be more like math. We set the screen value to screen value plus the new value, which I prompt the user for here. Yeah, this is a remarkable difference, that this is what is on this side is equal to this side. This side equal to this side. Whereas here I check to see if the action is equal to add, so this is more like a question, which is very important. Anyways, we can go to the program, check if the plus thing is working. I have 10 in my display and I want to add 150, and it gives me 160, which means it works. Exactly the same with the subtract. Here I have an else if the action is equal to subtract. I set the screen value to the screen value minus the new value. And same goes for multiply, divide, etc, etc. Maybe we should explain this modulus actually. The modulus works kind of the same way, but I set the screen value to an well, yeah, it's important with this modulus that I make the screen value an integer before I do it, as well as the new value. They must be integers, otherwise it would mess the calculation up. But as you can see, most of this should be working if I'm not awfully mistaken. So that was the minus. Let's divide 10 by 3. That gives me 3.33333. I can multiply that by 10. That gives me 33 point something. Let's just remove all the decimals. I will explain that one in a moment. But now I have 33, so I can take the modulus. Modulus divided by, say, 10. That should give me 3 exactly, because 10, 20, 30, and then I have 3 in remaining. So that's working. That's awesome. Yeah. Then we have the power. It's the power of something. Yes. So this one is included from the math library, where I take the power of yeah, the screen value and the new value. Let me just show this. Let's have if I have 10 here, I'll take 10 to the power of 2. That should give me 100, because 10 is the current screen value here. And I actually can't explain this. I think it has something to do with the math library, but I'm not sure. It's working at least, so sorry about that. Very important here in the end of the calculation thing. These are the calculations, and that's all pretty fine, but after all the if statements, I have to put out the screen value once more to make it actually display it. Very important. I messed around with that a lot until I found out what the problem actually was. Anyways, this one is actually interesting. It's the remove decimal. Put it in a function by itself. Like anything else, we take the screen value and put it equal to long double times integer times screen value. Basically, this means that I take the screen value and make it an integer, which will remove all decimals, but I have to put it back to the long double again, so therefore we put it here as well. But since we have the integer, it will remove all the decimals, and the long double can live without any decimals. So that's basically what it does, and I think I might have shown it already, but let's just take 100. Oh, we have 100. Let's just divide that by 6 or something. Then we have this, and we can remove all decimals with a D. It gives us 16. Please, and notice that in C++, when you remove all the decimals, you don't round it up or down. Well, basically always down, because it simply just removes the decimals and do not round anything up. So that's a good one to remember. Well, back to the main function here. First thing, cout, welcome to the Big Balls Calculator 2000, new line. And then we activate the display, which is pretty important for the user to be able to know what he or she is doing. Then we have the while loop, as I explained earlier, blah blah blah. I explained this. Yeah, basically it just consists of a switch case library which listens for the key presses. Yeah, that's if we take the subtract one here, for example, we have a case that listens for this character, which is a minus, and if it's that character, we activate the action called subtract. Well, no, we put action to okay, action will be subtract, and then we activate the calculation function, which is here, and then the calculation function searches for the if where action is equal to subtract. I hope you got that one, because that was kind of messy to explain. Anyways, pretty much the same all the way down until we reaches this one here. Remove decimals, well explained. This one, sine and cosine and tangents. Again, I put out this time I have to put out a string here before and say sine of, and then the screen value to make it easier for the user to see what he or she is doing. And then I set the screen value to be equal to sine of the screen value and put out the screen value again. I have to do this separately from the other part because yeah I kinda just have to. And please notice all these breaks here. If they weren't there, it would be really messy. Then I would be, for example, if I forgot to put a break after the sine part of the cases here, I would take, now we have 16 in the display, and I would take sine of that. If I didn't put a break after the sine case, it will continue and calculate the cosine of the same display or the new display, and as well as the tangent if I forgot to put a break there. So I have to break it to make it stop. Very important. Well, coming close to the end here, I have the square root function. It's pretty much the same as anything else. Yeah, I don't think I have to explain any of this. It's pretty basic. Oh, this one might be interesting. The power action. Did I explain that earlier? Well, it's at least here. Yeah, I did explain that, or tried to at least. Well, anyhow, and here I put in the case with the queue, so if the queue is activated, it says please come again. Very nice. And that's the function, the main function started with, as long as the key is not equal to q, the loop will continue running. But since it's q, it will put out please come again as the last thing it does, and then it will close the application. So let's see, remove all the decimals, gives us 0. Let's just put 10 in, see if I forgot to do anything. I can clear the screen with an O, and let's say goodbye with a Q. Please come again. And that's pretty much it. So I hope I recorded everything here, and hope I explained it quite thoroughly. Yeah, anyhow, thank you.